Well, in this video, we're going to go over altitudes. In fact, we're going to talk about two things regarding altitudes. We're going to talk about how to create an altitude, and we're going to talk about what they're used for. So first, let's talk about the things that make up an altitude. Out of this list here, connect to a vertex, 90-degree angle from a side, a base side, and connecting to a midpoint. Only two of those apply to altitudes. The reality is an altitude connects to a vertex. In this way, it's the same or similar to a median, because a median also connects to a vertex. But what makes it different from medians is that it has a 90-degree angle always. It's always perpendicular to the opposite side base. So let's take a look down below about what altitudes are used for. So, are altitudes used to find the area of a triangle, find the balancing point, or find the center of a circle? Well, when you think back about how we talked about what altitudes are, and we use the word altitude in its context, that is, sometimes people talk about altitudes when they're talking about very high places, like on a mountainside, or how high an airplane is. Well, an altitude has a definition associated with triangles, and that definition is height. The altitude of a triangle is in fact its height. So, it can be used to find the area of a triangle, because an area of a triangle is equal to its height, h, times the length of its base, all divided by 2. Altitudes, height, and area. Now, there are two steps to finding an altitude. The first is to pick a side you want to have the 90-degree angle come from. So I'm going to do the triangle up here on the left first. If I look at this triangle, I'm going to pick this long side. I don't have to pick that side. There are 3 altitudes. I'm just going to start with this one. The first step in finding an altitude is you want to put a ruler against that base. This is going to make it easier to use your piece of cardstock, like right here, to create a 90-degree angle. Notice that the edge of this cardstock right here is in fact a 90-degree angle. This is going to allow you to create the perpendicular part of the altitude. Putting my ruler right here. Now I'm going to slide the card so it is right firmly and squarely against the ruler. This is now creating a 90-degree angle along this edge. This is where my altitude is going to go. It's going to go right along that edge. But I also need that altitude to connect to a vertex. So, what I'm going to do is I'm going to slide this card until this edge intersects the opposite side vertex. So I'm going to keep sliding, sliding. Oh, there it is. There's the vertex. It's up here in the corner. And my altitude will connect from there to this opposite base. Now this is a 90-degree angle. So I'm going to go ahead and draw in that 90-degree angle. And here we found one of the altitudes of this triangle. Let's go ahead and find the other 3. So now I need to take the ruler, place it on this edge. Oh, but wait. If I place it on this edge, it's very difficult for me to line the card up this way so that it intersects the other vertices. So I actually need to line it up so that the ruler is on the outside of the triangle. That's key. Now I'm going to use my card and put it against here. I've got my 90-degree angle, and this is where my altitude's going to go. Notice it isn't currently intersecting a vertex. So what I'm going to do is slide this card over until it hits a vertex. There it does. Now I'm going to draw on the altitude. And And I'm going to put the 90-degree angle. This is the second altitude, and it corresponds to the base down here. Lastly, I'm going to put the ruler on the outside of the last side. Place the card, note card against this, forms a 90-degree angle, and I'm going to slide it until it hits, again, the other vertex. Put in my 90-degree angle. That means this altitude is perfectly perpendicular to this side. Now we've put all three altitudes in. Let's do one more that's a little tricky over here on the right triangle. I'm going to put the ruler on the outside, take my 90-degree note card, and I'm going to slide it until it hits the opposite vertex. Notice how when it hits the vertex, it's directly on this line. This is a property of right triangles. On right triangles, two of the sides, specifically the legs, are altitudes. So this is an altitude, and so is this side. Now that we have altitudes on these sides, and note we only really need one altitude to find the area, let's go ahead and find the area. I'll find the area of this triangle over here. If I want to find this area, I only need to use one height and one base. So I'll pick this height, it looks kind of short, and I need to pick the base that it's perpendicular to, which is this side right here. I need to measure both. So if I measure this, I get about 2.4 centimeters. So this is 2.4 centimeters. Then I need to measure the base that it's perpendicular to. Those two go hand in hand when calculating the area. Comes out to about 6.9 centimeters. So this entire length here is 6.9 centimeters. This is the base. So this is equal to B, and this part is equal to H. Using the formula, let's write out what this will be. So H is going to be 2.4, B is going to be 6.9, and I'm going to divide it all by 2. I'm going to grab a calculator. When I multiply 2.4 times 6.9, I get 16.56 divided by 2. After dividing by 2, I get 8.28. And technically the units on this are centimeters squared because it's an area. So the area of this triangle equals 8.28 centimeters squared. Looks like it's off your screen, so I'll write the word area there. You can use the same techniques on this one. You could measure the altitude, measure the base it's perpendicular to, multiply them, divide by 2, and you would get the area. You can do the same thing here. The nice thing about altitudes is it only takes one altitude with its corresponding base to calculate its area.